Hello guys, welcome to another session of Cassadara Learning. Today we are going to talk about object-oriented programming in Java. Before that, we will just get a recap of what we had learned so far, not just the previous session in entirety, because we are getting into a new paradigm of object-oriented programming. So far, we were doing the we are learning the fundamentals of programming, and we were discussing about the basics, like how we program very basically using data types and programming constraints and stuff like that. So since we are getting into the new paradigm, we will just revisit what we had learned so far. To start with, we had an understanding of what is a computer, what is a hardware, what are the hardware that are present in a computer by default, and then what is the software, how does it control the hardware, all that. Also, we classified software as system software and application software. And then we got into application programming because we are not worried about the system software for now. Our focus is on application. So for application programming, we we decided that we will start with Java language. Then in Java language, we saw what are the data types and the programming constructs. If you remember data types, we saw that there are several data types like int, char, float, double, long, short, byte, and boolean. Similarly, we saw about programming constructs like um, if, else, while, for, and then we also saw how to choose from a set of options using switch case. And then we saw about memory allocation and how we can continuously allocate the fundamental data type memory as arrays, like a set of characters or a set of numbers or a matrix or a list of names like two-dimensional arrays. So we saw everything so far, right? Okay. So what have we achieved? What were we able to achieve with all this learning? We were able to write simple programs to understand the input, process, and the output cycle better. And then we were able to perform arithmetic calculations. We were able to, do programming for add, subtract, multiply. We use the modulo operator, all that. And similarly, we made conditional decisions. We saw about how we decide whether a particular input year is a leap year or something like that. And then we also saw a program about choosing from a list of options. I believe we discussed something about choosing an ice cream, all that. And then repeated processing with iterative loops. We saw about that. We used a lot of that, even in arrays, even in iterating through the values of arrays. We use for loops and stuff like that. And then in array, we learned how to store a set of values, be it a set or a set of two-dimensional set or matrices kind of things. So how do we effectively store and retrieve values? We saw about that, right? So we with all these things we can write fairly complex programs, right? It's not that these are all very fundamental ideas. These are basic building blocks. So it's very easy using all these things to write a fairly complex program. But what we will miss here is the modularity. Like, say for example, if I want to do a process again and again, not repetitively, but sometime later again I want to do the same set of process, then if it's not modular, we have to rewrite the same code, which makes the program lengthy. If it's not modularized, it will be one long program like that. So the modularity will be missing. There won't be any ideas to further enhance the ability of the program, the performance of the program, all that. How can you make it error free when the program is long? If there is an error, we have to, it is very difficult to find and correct those errors. So all those things are there. So this is where we need a new paradigm. We need a new idea to how to write our programs, how to think, how to really achieve something big using these fundamental building blocks. So these are like if you look at uh, say for example your application is going to be a home. These are just brick and mortar, right? We have just created bricks and mortar. Now we have to build a home. But when we want to build home, we need engineering, we need idea, we need plan. So that is where we are getting into. That only then we will become real software engineers, right? So yeah, we will get into this new paradigm. What is it? It is called object-oriented programming. What is object-oriented programming? Why is it needed? Because we want the computer think like humans. What do you mean by what do I mean by think like humans? Humans have certain way of thinking. They organize certain information in certain way and then easily retrieve it when required, right? So that is how we need to process. So how does a human organize and store information in our memory? So we identify everything in this world as objects, and then we store an abstract version of the object in our memory. We'll see about that. So typically, if I can do the same to a computer, then the computer will also think like human mind. So that is the whole idea of object-oriented programming. We saw about this in a chapter called evolution. We saw a little about this, how the evolution happened, how the human thought process, uh, you know, uh, became everything, organized everything as objects and all that information, right? So similarly, so if you this is basically a continuation of that. So understand this: a human mind basically organizes everything as objects, and these objects has certain uh, how do we so okay how do we identify everything as an object? So an object basically has a use, a purpose, as far as a human is concerned. An object doesn't have any purpose, then we will throw it away. We will not store any information about it. We will consider that as garbage. Whereas if it is useful, it has a purpose, then we will see what are the physical properties that is there for that object, and then what function does it do. And then we store this information, abstract information. That is exactly what we are going to do. The fundamental idea of object-oriented programming here is to identify classes and objects. And then to abstract, the abstraction here means to abstract the idea of an object and take it as an abstract and store it as a class. Okay, so let me elaborate it in the next slide. And then we also, when an object is identified, when an object is created, it will it will encapsulate a set of properties and its functions. So it will be like a capsule. So we call it as encapsulation. And then an object also exhibits polymorphism. Polymorphism as an idea, I will tell you what it is. An object, when it is kept in different environments, when an object is moved into different environments, based on the environment, its behavior, its functions might change. That is polymorphism. So biologically, polymorphism is a word that is used to, you know, refer the behavior of animals like chameleon, where the environment color changes, the chameleon's color also gets changed. So typically that is what is polymorphism. And then inheritance. Inheritance is the capability of an object to um, to to render its properties to its children, right? To render its properties and functions to its children so they can perform the same thing. We will see everything in detail in the future, one by one. Now let us discuss what are classes and objects. The idea of an object is very simple, right? Everything, a human identifies everything as an object. So everything is an object. Say for example, if I ask you, what is this? What is this? This is a pen, right? You simply say this is a pen. What is a pen is an object. How do you identify this as a pen? You see the physical shape, structure, and then you say this is a pen. Because you already know anything that has this particular shape and structure and has a, nib, nib, the point, and then it has a cover, it has a body, and all that, then you already know it is a pen. You have a abstract idea of what a pen is stored in your memory already, stored in your storage of your brain. So when I simply ask this, you identify that with that particular storage and simply this is a pen, correct? So think about it. Now we'll see a physical definition. An object can be defined as anything that is tangible and has a purpose. And it has certain properties, physical properties like shape, structure, color, everything. And then it also has a functionality. What is the functionality of a pen? A pen writes. To write is the functionality of a pen, right? Yeah. So similarly, every object has a purpose, a function in this real world. And what is a class? A class is an abstract form of an object. So now remember I said you have an abstract idea of a pen that is stored in your memory, right? That is called a class, that abstract idea. So simply if I think about it, if I ask you what is a car, so you will say a car is something that has four wheels, a steering, an engine. You will try to define that basically, right? So you have an abstract idea of a car, you will try to explain that, you will try to define that. Whereas if I ask the question, what is your car? You will simply say my car is a Fiat or my car is a blue Fiat. You'll be able to give very specific answers, right? Because that is a real world instance. Your car means it is existing in this real world. It's a real world instance. So you are able to simply say, this is my car. Whereas if I ask what is a car, it is not a real world instance. It is only an idea. It is only an abstract idea. So you will try to define it. Correct? So this difference is the difference between a class and an object. A class is an abstract idea that is stored in a memory, and an object is a real world instance of that idea. Hope you get it, right? Have any questions? Please write me in the comments. So that is what a human brain stores an abstract definition of every object in it, and then it is using that abstract idea, abstract definition, it tries to identify those objects. Technically, when we write a class, we encapsulate the values, or values is basically the properties. For example, for a car, four wheels, steering, engine, seats are all values, right? So these are properties. And the function is to drive, to brake, to take a person from one point to another safely. All these are functions of a car, right? So you encapsulate these things and in a class as an idea and then store it in your brain. Similarly, we will define class and then we will store it in our system. So our programs henceforth all will be written as a class. If you remember, even our fundamental programs are written as a class, right? So now you understood why we every program we write, we say public class and their class name. So we are defining, basically we are defining a class with just a main functionality, just one functionality called main, and then we run that class, right? So similarly, we are going to write classes with which has specific properties and functionalities, and then we are going to save it and then create instances for it. And these instances are typically called objects. Okay, so now we'll see an example of how do we do that. Okay, welcome to the practical session. Here I'm writing a class called student, and in the student class, I define class is a public class student, and inside which, remember earlier we just wrote one main function for each class, right? But now I'm defining properties and functionalities. Properties are values. So what are the values student will have? A student will have his roll number, he will have a name, he belongs to a particular grade or class, and um, uh, let's keep that for now. So what is the purpose I'm going to give, or the functionality I'm going to give this to the class? The functionality I'm going to give to this class is basically to get data and then store it as a value inside the class, and then store it as a value in the object, and then print it out. Okay. So now I'm going to write the functions to get the values. So I'm writing the function public one get roll number, and roll. So here the value, past value will come here, and then I'm going to take this roll and assign it to the roll number in the object. So I say roll number equal to 4. I'm going to write another function for name. So the string, earlier using the fundamental, when we learned about the fundamental idea of storing a name, we saw that we use the character array, right? Java does provide a class called string, which encapsulates this entire manipulation of character array and all of that, and then it gives it in the name of a string. So we are using that. String is basically a class that is already provided by Java. So we will be directly using a string for storing a name. Internally, it will be a two-dimensional character, sorry, a single-dimensional character array, which we need not bother about it for now. So we will say public one. Sorry, this is set. We are setting the value, right? So set name string name. So I say name equal to name. Public one set grade. So we had set all the three values in the object. Now we need a function to get it. Public name. So when I say return, it will return the roll number as a value. Whenever I call this function, it will return the roll number of this object. Return that property. So this is going to be our student class. So it has value, it has functions to set values into the properties and then retrieve values from the properties. So I'm saving it, compiling it, done. So the student class is created. Now we have that abstract idea about student. I have given my computer the abstract idea about student. So now I'm going to use that. How do I use that? Let us assume I'm going to create another class here. Student util. So I'm going to utilize the student. So I'm just naming it student util. So I'm writing a class which is going to be a fundamental like a main function. Here, so I'm going to create ES1 equal to new student. So this is how I construct a student object with a new keyword. I construct a student object with a new keyword. Yes. And then this S1 refers to that object. It's a reference to that object, a pointer to that object. Like how we did for the array, we are just allocating memory for a student. Now the student object S1 of class a student of type student will not have any value. So I'm going to give some value. S1 dot set roll number 100. S1 dot set name. Okay. S1 dot set grade. Grade 6. Now I'm creating another object of student S2 equal to new student. So this is another object. Now S2, I'm just copying this 3 lines. just for the comfort. I say roll number is 101, Peter, and grade 7. Okay, now I have created two student objects, S1 and S2, of class student. So you see the difference now, right? Just the student which we defined here and then saved is an abstract idea of a student which has some properties and functionalities defined. And then it is like the idea of the car we discussed about, whereas the S1 and S2 are the real objects. So now if I ask you what is the roll number of S1, you will say 100, right? So it's a very definite object that is in existence, in memory. Now we had created objects and it is existing in the memory right now. So I'm going to see if it exists and by printing it. So using the get. So I will say system.out.println. The first object is s1 dot get roll number, comma s1 dot get name, s1 dot get grade. Now I have printed the values of s1. Now I'm going to print the values of s2 by using the get functionality of s2. So s2 dot get roll number, s2 dot get name, s2 dot get grade. Now when I print this, it's going to print these values. When I print this, it's going to, let us see. So, main function and the class. Save. Compiling it. I'm running it. So it is printing student 1 and student 2. So we have created two objects of the class student and stored value in it and then printed it, output the values. So this is how we write a class and then create objects. Alright, let us summarize what we have learned today. So object-oriented programming is a modern paradigm to make a computer think and work like a human mind. Since human mind stores abstract information about an object and identifies each and every object based on the abstract information it had stored. We are trying to emulate the same idea, and then we define abstract information about an object in a class. We define properties, we define functionalities, and then we encapsulate it in a class, and then we try to use this class to create objects for our programmatic use. So how do we do that? So we created a class called student. In our previous example, we created a class called student, and in student we define properties of the student like roll number, name, and grade. And for this we also define functionalities to get values and from the object, and then to set values into the object. We define functionalities for each property. We define a get and a set method, so the set function, and then based on that, so we save that particular property and functionality as a class. Now we use the class in another program called student util, and then we created objects using the new keyword new student, and then we use a parenthesis to create an object. Now we created two objects, S1 and S2. We independently stored values in S1 and S2 and then printed it out. So basically the object was doing the functions of storing and retrieving data from the memory. So this is how we define a class, and then we use it to create an object. Alright, hope you like the session. Let us continue with this. We have a lot to discuss in terms of object-oriented programming. Another 3 or 4 sessions are going to be based on the class objects, the nuances of defining properties, functionalities, security, all that stuff. So we will keep discussing this in the next session also. Thank you for your time. See you in the next session. Have a good day. Bye.